Topic number 2.2.1a, Insertion Sort algorithm. Let's see how algorithm works. Lesson goal. The purpose of this lesson is to understand what insertion sort is and how it works. Number 2, perform step-by-step dry run of the algorithm. Write the pseudocode for the insertion sort and implement insertion sort in Python and analyze time and space complexity. Okay, this is just only advanced topic, but it is good if you will learn about it. Okay, what is insertion sort? Insertion sort is a simple sorting algorithm. Sorting algorithm means it shows the elements in a proper arrangement or sequence. Okay, for example, we have two types of sorting. Number one is ascending order and number two is descending order. In ascending order mean every coming element is greater than the previous elements, like this. While in case of descending orders mean every coming element is the lesser as compared to the previous elements, 9, 10, 9, 8, 7, so on, like that. Okay, these are the examples. That builds the final sorted list one item at a time. Okay, they will sort list one item at a time. It works similar to how we sort playing cards in our hands. Start from the second elements. From where it will start? It will start always from the second element. Compare it with the previous elements. Okay, insert it in the correct position. When do we use insertion sort? It can work best for small list. If you have a small list, then it can work in a good way. Works well for nearly sorted list. Simple and initiative to implement. These are the three, you can say, benefits or the properties to implement this insertion sort. For example, here I have given one example. I will show you step by step. You have 7, 4, 5, 9, 10, 3, 2. Suppose this is the list. Okay, and you will start from the second element. Okay, second element means you will start from this elements 4. Key equal to 4. You want to insert 4 on the right place. Okay, you will compare the previous element. Previous element is on index number 0, that is 7. You will compare 4 is lesser than means key elements. What's the key element? Key is lesser element, mean 4 is less than 7. Yes, then you should do the comparison. Okay, what you will do, you can write 4 is at this place, and 7, then 5, 9, 10, 3 and 2. Okay, next key element is 5. This we can say no, key equal to 5. Now I will check that 5 is lesser than 7. You can see that in this case 5 is less than 7. Yes, it is true. Then we need a swap. Okay, now next array will become, or list will become 4, 5 and 7. Then I will write 9 as it is. 9, 10, 3 and 2. Okay, next I will came to the index number 3. Okay, that is 9. Okay, it means in this case key equal to 9. Key is 9. I will check that 9 is greater than with 7, less than, sorry. 9 should be less than 7. If it is less than 7, then need to be a swap. 9 is less than 7, no. Okay. Next, I will move the next element. Now key is 10. Key equal to 10. I will check that. 10 is lesser than 9. No. Then I will move key next. Next, I will check that 3 is lesser than 10. Yes. Then need to be replaced. Okay. After replacing, new list will become 4, 5, 7, 9, 9, and then 3, 10. This will move to the next also. 3 is, no, key is still 3. 3 is lesser than 9. Yes, it will be replaced. 4, 5, 7, then 3, then 9, then 10, then 2. 2 is here. Still key is 3. Okay, now it will check 3 is lesser than 7. Yes, it will move it again. Swap 4, 5, 3, 7, 9, 10, 2. Still key is 3. Key is 3. 3 is less than 5. Yes, swap. Okay, again 3 will check that 3 is less than 4. Yes. Okay, the new list will become 1, 2, 3, 4, 5, 6, 7. Okay, new list will become 3, 4, 5, 7, 9, 10, and 2. Okay, now I will move to the next element. Okay, next element is the 2. Key is 2. I will see that. I will write here in the new page. 3, 4, 5, 7, 9, 10, and 2. It will check key is 2 now. Now key is 2. Key equal to 2. It will check that 2 is lesser than 7, lesser than 10. Yes, 2 is lesser than 10. Then need to be a swap. Okay. New list will become 3, 4, 5, 7, 9, 2, 10. Next, they will check 2 with 9, less than 2 with 7, 2 with 5, and 2 with 4, and 2 with 3. Okay, they will need these swaps. Okay, after swapping all, the resultant list will become with me 2, 3, 4, 5, 7, 9, and 10. 1, 2, 3, 4, 5, 6, 7. 10 elements will be there. Okay, in this way it will sort. Now from what you learn that they will select one key and they will try to adjust that key until it will reach to the 0 location. Okay. Next, student, what is written here? Here I have written algorithm. Okay. For I will start from 1 to list of -1. Okay. Suppose you have 7 elements. Okay. 1, 2, 3, 4, 5, 6, 7. Suppose this is array name is list. This is 0 index. This is 1, 2, 3, 4, 5, 6. And you know that the value of length is 7. Length is 7 minus 1, 6. It will move from 1 to this position, 1 to 6. First they will check this key, then next this key, number 2, number 3, number 4, number 5, number 6. Okay. It will check the key. It will pick the key from these positions. Okay. See, key list of I will become the key, as they will pick key from here, then second, then third, fourth, fifth, sixth. Okay. What they will check? They will move j equal to I minus 1. Okay. J will move from j equal to I minus 1. Consider that they are taking this key. Here is I, and j will start from this position. Okay. And j, it will move until which position? 0. J greater than equal to 0. And list of j greater than key. The value, the list of j, see, list of j is greater than key. Okay, I told you in previous example, I see that 2 is lesser than. I'm checking reverse. I have written key is less than previous elements. Mean previous elements, all previous elements. Okay, they have written reverse. List of j greater than key. List of j plus 1 equal to, then what happen? It will match. Then list of j will move to the next position j plus 1. If j is on this position, mean this value will move to next position. This value move to next position. This value move to next position. That's why they have written j plus 1. And j is going to be decrease because it will reach to 0. J equal to j minus 1. And then if it will match where it will fit, the last key will insert it in that position. Okay. This we have implement. I will show you in the program. Okay. So this the program is written. Same way I have written the program. Okay. I start from length of values, key equal to I plus 1, values greater than j of key. J move till 0 as we have discussed this one. And what they will do, they will shift the value of j 1 plus ahead, and j is going to be decreased with minus 1. You can write j equal to j minus 1. J equal to j minus 1. When you will run the program, it will show the output 2, 4, 5, 7. Okay, if you will add one more element, 10, 3, when you will run this, it will show 2, 3, 4, 5, 7, 10. Okay, this is the program. You can see this one. 2, 3, 4, 5, 7, 10. Okay, student, I think you understand this code. Time complexity. Okay, case. Best case means already sorted. If I will give you a list that is already sorted, then this will run how many times the program will run? Big of n time. N means number of elements. If it is 7 elements in the list, it will run 7 times. And it is the worst case. For example, your list is already in reverse order. If you want to do in ascending order but list in descending order. If you want to do in descending order but list in ascending order, then it will take big of n square time. Okay. For example, best case example is I told you you can sort this list. Okay. 1, 2, 3, 4. 1, 2, 3, 4 ascending order. Okay, how many time loop will run? Loop will run 1, 2, 3, 4 time it will run only. Okay. And another example, if I will tell you, you can sort a list in ascending order of this list. 4, then 3, then 2, then 1. Ascending order. Then what have you? What have to do? How many time you have to do this one? Swapping or everything will be there. Big of n square time. Okay, n square time your loop will execute. Your total time complexity of the algorithm will be big of n square. If it is average case, for example, I told you, you can run like this way. 1, 2, 4, 3. This is average case. Then you have to run the code, then time complexity of this algorithm will become big of n square. Space complexity equal to big of 1 in place sorting. Okay, they will take only 1 unit. Multiple choice question number 1. Inserting sort builds the sorted list all at once, one element at a time, from a last to first, using binary search. No, one element at a time. Question number 2. Best case time complexity is big of n, big O of n. Okay. Multiple choice question number 3. Which element is selected each pass? First element, middle element, current element that is on key, or last element that is on key, that is current element. Question number 4. Insertion sort is efficient for very large list, random list, nearly sorted list, none. Nearly sorted list. Question number 5. Which operation is common in insertion of sort? Merging, swapping, shifting element, and splitting. Shifting element. In this insertion sort, we are shifting elements to the next position. Question number 6. Worst case occurs when list is empty, list is already sorted, list is reversed order. The list is reversed order, then worst case can happen. Question number 7. Insertion sort is a divide and conquer algorithm. No. Comparison based algorithm, hash based algorithm, tree algorithm. It's on comparison based algorithm because we are comparing the algorithms. We are comparing the elements. Programming task 1. Write a program that sorts 5 user entered number using insertion sort. We will insert 5 numbers in a list and then we will sort it. This is the same sort, insertion sort is there as we did last program. Okay, but what I did, for I in range 5 times, they will ask me number 5 times, and all the time they will values dot append. They will append in the list. Okay, what number they will show in form of integer number. Okay, and after this they will call this method insertion sort. They will call this method with this list values. Okay, and after this they will show me printed values. When you will run the code, okay, I'm going to run the code. Enter the number. I have entered the number 65. Enter the number 100. Enter the number 3. Enter the number 4. Enter the number 6. Now they are showing me sorted list 3, 4, 6, and then 65, and then 100. Okay, how many numbers they are asking? 5 numbers. Why? Due to this loop 5 times. Okay, they are appending, they are making into a list, that is values dot append, by using this function. Append is a function, built-in method function that is used to get a value and put at the end of the list. Insertion sort, they are calling insertion sort with these values. Task number 2. Modify insertion sort to sort the list in descending order. They want in descending order. Just we can change, reverse the symbol. Okay. How will reverse the symbol? You can see that a program has written here. Program number 3. This key is changed only. Value key J less than key. Okay. When you will run this program, what happened? They are checking according to this. Okay. Only I have changed here key. When you will run the program, enter the number 2, 3, 5, 6, and 1. When you will run this, it will shows me 6, 5, 3, 2, 1. Okay. Only they are changing this key. If you will make it greater than, what happened? They are showing me in ascending order. 34, 56, 12, 7, 20. Okay, see 7, 12, 20, 34, 56. Okay, you have changed only this key. When they will when you will write less than, then it will move to the descending order. It will shows in descending order. 23, 45, 1, 2, 78. 78, 45, 23 to 1. Okay, student clear? Next is task number 3. Count how many shifts happen during insertion sort. Okay, we will write a program. How many shifts happen? We're moving to question number 4. Okay, what happened here? This is the same name of the array function. Shift by default shift is 0. They will run the same method from same do from 1 to length of values mean -1, and they will first pick a key and j will move to -1. J will start from previous value of the key, and j will move until it will reach to 0 point, and they will check that value is greater than key. Then they will shift the value to the next position. Okay, and after this they are counting the shift, how many times they did the shift. Okay, and then after they are showing returns, how many shifts are there, and I'm showing here shifts are I'm saving, I'm restoring the shifts in total shifts. They will show me what is in how many shifts has been happened occurred in a sorting list. When you will run the program, you can see that list is giving there. Original list is 6, 17, 8, 1, 2, 9. Sorted list is 1, 2, 6, 8, 9, 17, and 8 is there. Okay, because I have given this value. Okay, what happened? I am getting 17 in place of this control X and moving to the last position. Last position, you see that. You can see that shift will be reduced or not. When I will run this, see that 4 shift happens. Okay, same way what I am moving 8 to the right position. Suppose control X, I am writing here comma 8, comma 9. Okay, now you can see that 6, 1, 2, 8, 9, 79. I want to check how many shifts are there. When I will run this, 2 shifts are there. Okay, what I will do, I am moving 6 also, control X, from this position to this position. Okay, now I will run the program. When I will run the program, they are showing me 0 shift, no shifts are there. Okay, because this is already in sorted list. This is the last. If you find any difficulty, please write me in comment.